All right, let's dive into something that, honestly, it sounds like pure science fiction. We're talking about a living battery.
And get this battery, it runs on something we all produce every single day. So just think about this for a second. What if the water we flush away could power our homes? I know, it's a wild thought, right? But that's exactly what we're going to unpack today.
Now, to really get your head around this, you kind of have to flip your whole perspective. Traditionally, we see wastewater as this costly problem, right? A liability that just guzzles energy to clean up. But this new way of thinking, it flips that script completely. It says, hey, that's not waste. That's a hidden resource. It's basically chemical energy just sitting there. The whole goal is to turn our treatment plants from places that consume energy into places that actually produce it.
Okay, so let's get right into it. Section 1, the power in our pipes. We're going to talk about the incredible potential that's literally flowing right under our feet.
So here's the key takeaway. All that stuff floating in our wastewater, it's not just pollution. Think of it as fuel. It's this dense, untapped vault of chemical energy, and it's just waiting for someone to find the right key to unlock it.
And you guessed it, that key is what scientists are calling a living battery. So you're probably wondering, how on earth do you build one of these things? Well, it all comes down to this core technology, the microbial fuel cell, or MFC for short. The easiest way to think about it is like a regular battery. But instead of harsh chemicals, it uses living, breathing microorganisms to turn the energy in organic waste directly into electricity. It's basically a bioelectrochemical engine. Pretty cool, huh?
But how does it actually work? Let's break it down step by step. So, you've got this chamber with no oxygen. In there, bacteria hang out on an electrode, that's the anode, and they start munching on the waste. As they digest their meal, they release two things, protons and electrons. Now, the electrons are the magic ingredient here. They shoot off through a wire, and boom, that's your electrical current. That's power we can use. Meanwhile, the protons take a different path. They cruise across a membrane, meet up with the electrons and some oxygen on the other side, and you know what they make? Clean water. It's just this elegant, beautiful, self-contained system.
So you gotta be asking, who are these microscopic heroes doing all this heavy lifting? Well, let's meet them. These are the electric microbes.
All right, so there are two main superstars in this microbial world. First up, you've got Geobacter. I like to call this one the engineer, and for good reason. It actually grows these amazing little conductive filaments. They're called nanowires, and it literally builds a living circuit right there on the electrode. Then you have Shionella, which is more like the courier. It doesn't connect directly. Instead, it sends out these tiny little molecules that act like shuttles, grabbing electrons and ferrying them over to the electrode. So yeah, two totally different strategies, but they both get the same incredible result.
And the potential we're talking about here is, well, it's just staggering. There's this one quote from the research that really puts it into perspective for me. It says, "The bacterial nanowires of Geobacter may very well be the power lines of the next generation." I mean, just let that sink in. We're talking about a fundamental shift in our infrastructure, all powered by tiny bacteria.
Okay, so just how much energy are we really talking about? This chart gives us a great visual. It's measuring something called chemical oxygen demand, or COD, which is just a way to quantify the energy packed in there. Now, look at the first bar, domestic sewage. Decent amount of energy, right? But then look at what happens when you get to agricultural waste or industrial waste from, say, a brewery. Whoa, the potential energy just skyrockets. And that's where this technology could be an absolute game changer.
This all sounds amazing, right? Almost too good to be true. So the obvious question is, why isn't this everywhere already?
Well, it turns out that going from a small setup in a lab to a full-blown treatment plant is tricky. There are some major hurdles. For one, you've got this thing called internal resistance. You can just think of it like friction that's slowing down all those electrons and protons. Then there are the material costs. Some of the key parts, like the membranes, are still pretty expensive. And finally, there's what's called mass transport, which is really just a fancy way of saying you have to get the fuel to the bacteria fast enough. It's a really complex engineering puzzle, but believe me, researchers are working on it around the clock.
But here's the good news. Researchers are cracking that puzzle, and the future they're building, it's all about being circular. And what's super cool is that this basic idea, the MFC, has already started a whole family tree of new tech. You can tweak the system just a little bit, and suddenly you're producing hydrogen fuel. That's a microbial electrolysis cell. Or you can use that same electrical juice to pull salt out of seawater, creating fresh water with microbial desalination cells. They can even become these tiny, self-powered pollution detectors. So, you see, it's not just about electricity anymore. This thing's a whole versatile platform.
So, it all comes back to that big idea we started with, that huge paradigm shift. We're moving away from this old, straight-line model of treat the waste and dump it. Instead, we're moving toward a circular model of resource recovery, where waste isn't an endpoint, it's a valuable starting point.
And that really leaves us with one final, pretty mind-blowing thought. Everything we're trying to get, clean water, renewable energy, even real-time data. The code for all of it is already hidden in our wastewater. So the question isn't if we can unlock it anymore. The real question is, are we ready to?